Evening, good morning, good afternoon, depending on what time zone you're in, where you are. Welcome to Areopa and our presentation today. Our presenter is Tobias Fenster. He will be presenting about Docker. The topic is clear on the screen here at the moment. I'm filling in for Luke. Luke had an emergency he had to take off to today. So I'm David Singleton. I've been moderating a few of these, so some of you will already know who I am. We're about to get going. Before I hand over to Tobias, I just want to do some housekeeping. Okay, so some housekeeping rules. Firstly, your mic is already muted. You can't actually talk. So if you have a question, there is a question and answer field. If you type a question in there, I will be addressing those technical questions relating to the presentation. I'll try to answer immediately. In terms of questions about the presentation for Tobias, if it's a question relevant to exactly what he's saying at the time, I will interrupt him and pose the question so he can answer it in line. If it's a question that is not specific to the actual topic that he's on at the moment, I'll wait till the break or till the end of the presentation, and we'll have a 5 or 10 minute Q&A at the end of the presentation. So please put your questions in there so we can see them. So I will pick them up as the moderator and hand them over to Tobias. Right, so please subscribe to our website. We now have enough subscribers that we have an official Areopa name now on YouTube, so that's really good. Please go and look at the historical ones. Everything is recorded. Everything is available for you to see at a later stage. Here is the link. You can also find them at the Areopa website. It's areopa.academy. So you'll also subscribe to the newsletter. Be aware that with GDPR requirements, you do have to actually subscribe. If you were subscribed before, you've lost that, you'll have to resubscribe. Okay, so those are all available. Just quickly, our next coming webinar will be after Christmas on January 21st, and it will be Upgrade to BC. How do you do that? Luke will be giving that presentation, and I hope to see you all after the Christmas break. So remember, we're always looking for new topics and presentations. Anything that is relevant in the BC world would be really useful. If you've got a topic you'd like to present, join in on this, present it. Keep in mind that this adds to your online presence and gets your name out there. And it's just a good way to help feedback into the community. Also, it's since you have a practice, if you were planning to go to any of the big events like TechDays and you want a bit of practice beforehand, this is a really good place to get a feel for what it's like to talk in front of an audience without the actual audience being there, so it's a little bit easier. Okay, now, of course, a big thank you to 4Nav, who are our sponsors. These webinars don't come free. There is a financial aspect to making them happen. The technology behind it, the go-to webinar, etc., has to be paid for, and that's done by 4Nav. So thank you very much to Jan and Michael. So thanks for everybody, and at this point, I'm going to hand everything over to Tobias. So Tobias, it's all yours.
Perfect. You should be seeing my screen now.
Yes, you are on. I'll let you know if it's stopped. I can definitely see your screen now.
Okay, perfect. So welcome from my side as well. The topic has already been very well introduced. Thanks a lot for that. So I'll start with introducing myself. I work for a company called Cosmo Consult. My name's Tobias Fenster. I'm the CTO for Cosmo Consult, and I'm a dual Microsoft MVP for both business applications, mainly NAV and Business Central, and also for Azure. And if you want to get in touch or follow what I'm doing, you can find my Twitter handle, my blog URL, and my contact data right here. So without further ado, what are we going to talk about? Now, I think the starting point for this is someone who's already running or wants to run the dev or test environment for NAV or for Business Central in Docker containers. So I'm not gonna go into details of what Docker is and why you would use that or anything like that, but I'm assuming that you are already familiar with the base concept. And I assume that you want to run multiple containers on the same VM. And I also assume that you have solved the networking challenges that come with that. If you didn't, then please check the webinar on Areopa as well that I did on October 1st, where I shared multiple ways to get that up and running. But for the moment now, I'll assume that you have Docker containers, you're using them for whatever purpose, and there are multiple containers running on the same VM. Now, the challenges and the limitations in that are that you might run into situations where you have where you need more resources that one VM can provide. So for example, you're running in a bigger team, you have multiple people that are running maybe on multiple projects, you need old version, new version because you're doing upgrade projects or whatever. You just run into a situation where one VM isn't enough for the resource needs that you have. So of course you want to scale that up, and that would kind of be easy by just adding more VMs. So then you not only have the resources of one VM, but you actually would have the resources of multiple VMs. But again, depending on your scenario, that might not be that good because you will need to let people know which VM to use, how they can connect. So that also might be a bit of a hassle there as well. And you also might want to dynamically scale up and down. So depending on your current need, you might want to add further resources and not always go through the full process of setting everything up, bringing new containers in, letting people know how they can connect to your brand new VM. And then next week, and when the resource demand goes back down because you maybe have finished a couple of projects, then you will need to let them know that now the containers are running on different VMs or something like that. And also, you might want to consider not running the SQL Server in the container that is coming with the Business Central container. There are multiple reasons for that. If you think about it, then if you're running 20 of the Business Central containers, then of course you're running 20 NSTs. That is not too much that you can do about that. You could run multi-tenant, but if you're developing, that probably is not an option. So having 20 NSTs is a given, but if you run that strictly in the way that the Business Central containers are set up, then it also means that you're running 20 SQL servers. And of course, that's absolutely not the way that SQL is intended to be used, and it doesn't make a lot of sense. You're adding some overhead there as well, so that's not a very efficient usage. Also, the SQL Server in the container is SQL Express. So as soon as you're talking about databases bigger than 10 gigabytes, that's also not working. And again, you will just run into scaling limits because, again, you're running on a VM, and as soon as the resources of that VM are exhausted, then also your SQL Server will be exhausted. So basically, you run in a lot of the same issues that we're having with the NSTs or with the NAV part of this. So the solution for that comes in two parts. The first part is the one on the left, Docker Swarm. And the second one is SQL on Azure, or Azure SQL in combination with an Elastic Pool. And just wanted to let you know that those are the two main topics that we'll cover today. And now I'll get into more detail. So I'm not assuming that you know those already. Part one of the solution is a Docker Swarm. To give you a bit of an introduction here, Docker Swarm is the built-in container orchestrator from Docker. Container orchestrator means that this is a solution that is not only thinking about one single container, but it's really thinking about a lot of containers and how you can just orchestrate those. That means you can manage them, start them, stop them, bring them somewhere, make sure they're connected, make sure they're available, and so on. The base idea, and you can see that in a bit or to a degree from the logo, is that you bring multiple container hosts together. So as you can see, we have multiple of those lovely whales carrying the containers, and that's basically the idea of a Docker Swarm. You have multiple Docker hosts, you bring them together in one big virtual entity, which is the Docker Swarm, and then you can just run your containers on them, and the resources will be to a degree shared. We also have a central management and control interface. So we're just talking to the swarm. We're not talking to the individual container hosts. And I'll also show you in a minute why that is beneficial. We can share configuration and secrets. Now, if you think about the scenario that I kind of lined out in the beginning, where you have multiple container hosts that are not connected through a swarm, but just managed independently, You would let all of them know where your SQL servers are. You might have secrets like access data, passwords, usernames, whatever. You would need to make sure that this is shared across all of your different container hosts. If you go for independent multiple container hosts, that's also where Swarm can help you, because you just define the configurations and the secrets once, and Swarm will make sure that this is shared across the whole Swarm and the whole container hosts that are connected. It has a declarative service model. That means that you basically just tell Swarm what you want and it takes care of the rest. You don't have to specify all the details or go through all the steps, but you just let it know what the end result is and Swarm will handle it. It has some automatic self-healing concepts. That means that if one of the containers fail, the Swarm is able to recreate that one and make sure that you're always in the desired state. And I'll also show you how that works. And then it has some advanced networking options for resiliency. So again, you don't need to tell your users that they have to connect to a specific host, but they just need to connect to this overall Swarm, and networking will just work. And then some words, as maybe some of you have heard about Kubernetes, which is the de facto standard in container orchestration. And then there was some news going around a couple of weeks ago that Docker was sold to Mirantis. And I want to talk 2 minutes about why that matters and why still Docker Swarm is, at least in my opinion, a valuable solution that is worth investing. Kubernetes definitely is the de facto standard in the industry, but Kubernetes is really about microservices, about handling applications that consist of a lot of containers. So you have your one application, logically speaking, but that one consists of dozens or maybe even hundreds of containers, and those are stateless. They can be started and stopped very quickly. They can be recreated. The scaling there works just differently. Now, the Business Central images for Docker are a really amazing feat and really have brought us forward, but they are definitely not a stateless microservice. They are stateful and they are a macroservice, so to speak. As they contain NST, they contain SQL Server. They are really very big. So the concepts that Kubernetes brings are not very valuable if you apply them to the Business Central world. And in my opinion, Kubernetes has a kind of steep learning curve, and you have a lot of things to worry about, to configure, to understand, to make them up and running. And that is something that you don't want to, again, in my opinion, you don't want to take that time if you only plan to run your Business Central images or your Business Central containers, because those don't benefit too much from the features of Kubernetes. That's why I think that while the industry as an overall is moving toward Kubernetes or even other container orchestrators and moving away from Docker Swarm, I still think that in our scenario, running Business Central containers, it makes a lot of sense to look at Docker Swarm, because that's very easy to set up and start. And then what actually happened with the Docker selling to Mirantis. Now, Docker sold the enterprise edition part. That means that the enterprise targeted parts of Docker were sold to Mirantis. That's a Kubernetes service provider as well, so it's going into that direction. And in that context, they announced that they will have only limited support for Docker Swarm for 2 more years. But that really is about the enterprise edition. And I very much doubt that anyone in the Business Central world is using the enterprise edition. I would guess that everyone is using the version that's coming for free with the Windows Server. So there's really not too much to worry about in that regard. I've talked to some people inside of Docker who told me that Docker Swarm will still live on in the open source area and still will be supported. And until I hear anything else, I assume that is true. So from my point of view, again, it makes a lot of sense to still invest into Docker Swarm. Now for a couple of basics in the Swarm world that I will use during the upcoming presentation. If we're talking about a service in the Docker Swarm world, then this is basically the thing that you want to run. So you let Docker Swarm know that you want to run a specific image. You let it know how many of the containers of that image you want to run. And the word for that is tasks in the Swarm world, and the configurations that you want to run. So I wanted to connect to a specific SQL server. I want to enable SSL. I want to use Windows authentication. Whatever you can think of that you will add as configuration parameters to nav container helper or to the Docker run command, if you're using that, that is something that you will need to specify on the service configuration. Those services can be either replicated or global. Replicated means that you let it know you want to have 3 of the tasks or 3 of the containers, and it will put it somewhere on the nodes. Or you can have it global, which means that you want to have 1 task per container host up and running. So it's basically putting the containers on every container host. Now we have the node, a word that I just used. A node is one of the container hosts, or actually Docker engines that are joined to the swarm. So if in my example as before, you want to scale your swarm, that means that you start a new container host, you join it to the Docker swarm, which is an easy 1-line command, and that will make it a node of that Docker swarm. And then there are 2 specific or different kinds of nodes. The first one would be a manager node. That's a node with control rights. So that one can create services, stop services, start services, pull images, all that administrative stuff. And then we have the worker nodes that can execute tasks. That means that they don't have any control access, but they can just execute the containers that we specified. A manager is also a worker in a sense that it can execute tasks, but a worker can never be a manager, so it can't get control rights and it can't manage the swarm. So if we now want to run something on a Docker swarm, what does that mean? First of all, we would need to declare the service. So again, we would need to let it know what image, how many containers, what configuration we want to run. You would submit that to a manager node. So we would let Docker Swarm know that we want to do this. And then Swarm will do all the rest. It will create the necessary tasks. It will keep the desired state. So if I tell it that I want to have, for example, 2 tasks or 2 containers up and running and 1 fails, then Swarm will automatically recreate that instance and make sure that I'm back at my desired state of 2 containers. But we'll go into that in a practical demo in a minute as well. To show you the benefits, if you still think in the old world where you might have 3 different Docker hosts, and now you want to run 5 containers on those 3 hosts, what would that mean? You would use your client to connect to the first one. The first step is to create the first container. The second step is to create the second container. Then you connect to the second Docker host. You create a third one. You create the fourth one. And then you connect to your third Docker host and you create the 5th one. So basically, to get 5 containers on 3 hosts up and running, you will need to open 3 sessions to those hosts, and you would need to set up 5 commands. If you do the same in a swarm, so we're in the same situation, we have our Docker swarm, but we think about that one as a virtual entity, and now we want 5 containers running inside of that swarm. It's just 1 command, and all the containers will automatically be started and will be up and running. Of course, behind the scenes, we still have our 3 container hosts, and those will have different roles, as I just shared, managers and workers. So actually, behind the scenes, that's kind of similar to what we've seen before. But the big benefit is that I'm not directly connecting to those different hosts for the management work, for the handling of the containers, but instead, I'm just connecting to that virtual entity, to the swarm, and it will handle all the rest and will make sure that my containers are placed and started and up and running and so on. And then I've also talked about the networking stuff that happens inside of a Docker swarm and how we can use that. So to give you a graphical example of how that works, if I connect from my client to one of the nodes and I have set up the services correctly, then I am able to connect to one of the tasks or one of the instances of my service that are up and running. But Swarm is clever enough that if I just then do the connection to a different node in that Swarm, it might even redirect me to a container on the first one. So while that doesn't make too much sense in that scenario, it's very important if you think about the case where someone connects to a node that doesn't have one of the tasks up and running. So in that example, I'm connecting to the third host. I want to connect to my service, and now the Swarm is able to redirect me to a service that is running, or to a container that is running on a different node. So that means in that scenario, I would only need to let my users know that I can connect to any one of the container hosts, and they are able to reach the service. Whether it's running on the same machine, it's running on a different machine, or as in that example, the machine they connected to doesn't even have one of the containers up and running, that doesn't matter. They still will get the connection, and it's easier for me to handle the networking. I don't need to worry about which container is running on which host. They are just reachable for my users. Please note that this doesn't directly work with Business Central, as that would again require a stateless service. So that is something that we need to handle differently, and we'll see in a minute how we can do that with Business Central. Just wanted to introduce that concept to you, as it's very important in the Swarm world. The second thing, and that one directly applies to Business Central, is that services are able to find each other no matter on which host they are running. So if you imagine an application that consists of two containers, for example, we have a Business Central container and a SQL container, or an IIS container and a Business Central container, or whatever. It's just two containers that are working together to provide my application. And someone connects to the first one, and now the first container needs to find the second service that also works across container hosts. And they are just able to reach each other by name. So if I deploy my application to my Swarm and I know that I have one service that's called Business Central and a second service that's called SQL, then I can just configure the Business Central service to connect to the SQL service. And I don't need to worry about if those are running on the same container host or if they are running on different container hosts. That just works. So if for whatever reason my, for example, SQL container would switch hosts because the worker went down or for whatever reason it got recreated, then still the Business Central container would be able to reach the SQL container because it doesn't matter on which container host it's running. So with that introduction, I want to step into the demo. My demo scenario is one service that is consisting of two containers. It's an easy service that will just show a hello world and the ID of the container, so we can see to which container we are actually connecting, and we will check the connections that are up and running. Then I will show you how scaling works, so how we can scale up that one, and what happens if we remove one of the tasks. Of course, we want to see how that one recovers with the automated setup of the desired state that I just talked about. So let's look at how that works. First of all, here I should hopefully still have a connection. Yes, so this is connected to a virtual machine on Azure. Oh, switch back. To a virtual machine on Azure that I've set up, where I already have a Swarm up and running, and I'll show in a minute how that setup works. And now we will create a service, and I'll copy and paste that one so you don't see me mistyping stuff. I run it and then explain what is happening. So we're doing a Docker service create. We're creating a service. We give it a name. So the name of the service will be say hello. We want to have two instances of that up and running. We want to be able to connect to port 8080 in order to get to port 80 on the container. So this is just letting Docker Swarm know how we want to connect from the outside. We want to run this not on a manager node. We just want to run that service on worker nodes, so we can specify that one. And this is the image name. So in the Business Central world, that would be mcr-microsoft.com/business central and so on. But in my case, just to show you the Swarm stuff, I've created that one. Now, if we connect to that one, let's see. So again, I've set up port 8080 to connect there. If we go there, okay, we can see here we are connected, and we are connected to an instance with that name. So that's the ID of the container. And if I now reload, you can see I'm still connected to the same machine, to the same port, but because of the service sharing or the networking stuff that I just introduced to you, we are now connected to a different container. If I reload again, I might get the same. Now I get the same, now I get a different one. So that just changes. Let's look at how this actually works. So if I go to Portainer, maybe you're familiar with Portainer. That's a graphical tool to manage your containers, and that has Swarm support as well. So if we look at that one, we can see that it has 8 containers up and running. A couple of those are for management only, or Portainer itself. But we also can see that we have 4 services, and one of those services is our say hello service. So if I expand that one, then we can see we have two tasks, those two different containers that we just connected to. One is running on our worker 0 node, and one is running on our worker 1 node. So to get an overview of my swarm, I can click on swarm here, and then I can go to the cluster visualizer, which I'll do in a minute. Something else I want to show you is we have the CPU and memory allocation below here. So you can see I have a somewhat small manager node, and then I have bigger worker nodes. And the way that Swarm thinks about that one is that we have that amount of total memory and that amount of total CPUs. Of course, we can't scale across VM boundaries, so we can't use more than 8 CPUs for one and the same container, because that would be going across. But basically, by using those 3 container hosts, we have created a big swarm with those resources that I mentioned up here. Now to visualize that one, you can see here, we have the manager node. That one has Portainer, it has traffic. We're not using traffic at the moment, but we'll do in the next demo. And we have those agents, those are necessary for Portainer to work. And then we have our say hello service here, and we have the second instance here. So you can see that those were spread across those 2 workers as well. Now, for example, let's say we need more of those. So we go back to the services and we scale it, and we tell it, I want 5 now, and click on OK. Then you can see that the worker 2 has accepted that one. Those 2 are preparing. And now if I reload, because it's a very small image, we should already see them up and running. So if I go back to the swarm and the visualizer, then you will see that we have an additional one on worker 0, and we have 2 new ones on worker 2. If I now go back to my application and see. So I think if I remember correctly, we haven't seen that ID before. So we already are connected to one of the new instances. And if I reload, we should get, yeah, that's another one of the new ones. So it already has integrated those new instances into the networking and is connecting to those instances as well. So my load balancing works there. I can, of course, do the same backward. So if I go back to the services, let's say I don't want to have 5 anymore. Now I want to have 2 only. Then it's just removing those instances. And if I refresh, they should already be gone. So now I'm back to 2 instances on worker 0 and worker 1. And that was me telling Swarm that something happened and I want to scale back. What I, of course, can also do is I just can kill one of those containers. And that way, kind of simulating a crash. So if I go here and just remove that one and accept that, and if I'm quick enough and I go back to the services, then yeah, you can see here, Swarm understands that that one has failed. So it just has gone away. And because I directly connected to the container to delete it, Swarm doesn't understand why that happens. It just went away. But it also automatically has recreated an instance or a task for me, because I told it I want to have 2. 1 got away, so of course it's creating a new one. And if I refresh, that one should already be up and running again. You also see that it has failed on worker 1, and it has recreated that one on a different node on worker 0. So again, you see that this is really working across my container hosts. I don't need to worry about the different container hosts that are up and running. I just can use them, scale up, scale down as I need to. Okay, then a minute for the initialization of how all of this works. So to show you that one, this is the initialization. There is a couple of setups steps that are necessary for traffic, but we're not using traffic. So if you wouldn't have a traffic setup, then the things that you would need to do is setting up TCP traffic on those 2 ports, so opening firewall ports there, UDP traffic on those 2 ports, and then for my hostname up, I've also opened the port 8080, but that is dependent on the application that you want to use. And then we're just doing a Docker Swarm init and give it the IP address that we're using on that machine. And that will make that container host that we are running on the first container or the first host in the swarm, which makes it a manager node. And then it will return something that looks like this, Docker Swarm join, and then a token. And we will need to use that token to let the other container hosts know, so they know how to join. So basically, they need a secret to be able to join the host, so that not someone can take over my swarm, but instead they just need that token, and then they can connect to the manager, let it know I know the token, and with that they are joined. And to show you how that looks like on the command line, I can also do a Docker node ls, and then we're seeing basically the same that we've just seen in the visualizer. We have the manager machine that I'm connected to now. That one is the leader, and it has a star here because I'm on that one. And then you can see the 3 worker VMs that are just connected there. You can also see the engine version over here. So I can also do some things like, if I want to update my Docker version, I can start with my first container host. So I remove it, everything's still running because the nodes are rescheduled to the other container hosts. I update my engine version, and then I go host by host. And in the end, my containers are still up and running. The users ideally wouldn't even notice that I did something, but I still have updated my my Docker version or my Windows version or whatever I need to update, because I can do this host by host. Okay, so with that, and that was the introduction to Docker Swarm. Now, as I said, this is only the first part of the solution of a really scaling environment. The second part is Azure SQL and an elastic pool. So to give you a very brief introduction here in the theory, as I guess a lot of you already know what Azure SQL is, that's a platform as a service offering. That means that you're just using SQL as it is. You don't need to worry about management, about updating, about configuring, maintenance, whatever. It's kept current by Microsoft. You can scale it up and down dynamically with almost no resource limits. So you can really go very big in Azure SQL. Now, if we do that just by one database, then we're running into the same issues. Is that database big enough? Is the scaling big enough? Now someone is not using, or no one is using that database anymore, then still the resources are bound to that one database. So we don't want to do this on a database basis, but instead we can use something that's called an elastic pool. And that elastic pool allows resource sharing across all the databases. So I'm basically telling it I want to have a pool that has that amount of CPU and that amount of memory. If I want to scale that way, then I can just put as many databases in there as I want. And if only one database is active, then it can have all the resources in that pool. And if 3 databases are active, they just share the resources. So that way I'm able to handle peaks very easily, because it's probably not that probable that a lot of users are having peaks at the same time, especially at a development scenario. So when someone deploys and an upgrade needs to run, then maybe that one needs a lot of resources, but at the same time, 5 other developers are just working in AL, working in their local VS Code there. So there's no load going on a SQL side. And then someone else comes up and does the upgrade as well, or does a deployment or whatever. And then the resources are switched to that database. So that way we're very easily able to have dynamically scaling environments. In that case, we have no server maintenance to do. We have almost no limits, but of course we have to pay for that. So there's a cost that's connected to Azure SQL, of course. So just to recap where we started from, we understood that we might need more resources than one VM can provide. We needed to dynamically scale, and we needed to run something else as a SQL server, so we can again have the same scaling options. And as I hope I just explained to you, the solution for that might be a Docker Swarm, and then SQL, and then Azure SQL and an elastic pool to handle the SQL side of things. So to bring it all together, we are using Swarm and also Traffic and Azure SQL to solve our problem of having really scalable NAV or Business Central environments. Traffic, just to give one sentence about that one, is a reverse proxy that helps us with the networking stuff. Again, if you don't know how that works, just rewatch the Areopa webinar of October 1st, where I've introduced that one. So I'm assuming in that case that I have an Azure SQL database with a template. So how that would work is that you would, for example, use all your products or the standard Microsoft environments and put them as template databases into Azure SQL. And then what happens when we start our service, as we will do in a minute, then it will just use that template database, create a copy inside of our pool, and connect to that one. The deployment works through an ARM template, and I'll show you briefly how that one works as well. So if you're wondering how can we set that up, that basically is one script again, calling other scripts, of course, but it's an easy one-line command if I want to set up a new swarm and a new Azure SQL environment, because I use an Azure Resource Manager, that's what ARM stands for, to deploy that one, and it brings up one manager VM and as many workers as I want to. In my scenario, I have 2 workers set up, but I could run 5 or 10 or however many I would need. Now that one manager, of course, is a single point of failure. So in a real production environment, you would probably go for 3 or 5 managers so that you're really safe there. I have one Azure SQL Server with one Elastic Pool. Again, you could set that up differently if you need to, but for the demo scenario now, that works very well. I have the script to initialize the swarm that we just looked at, to join it on the workers and to set up traffic. So that's what I already showed you. And then I have a script to prepare the access credentials, because the containers that are up and running, they need access to the template database to kind of read it. And we also need access to the target pool so we can share the secrets. So as a specific scenario, I want to start a BC Swarm service, and I want to connect it to a database that's created on demand as a copy of the template. So really at the moment, we only have the template. I created a fallback service in case anything goes wrong, but for the service that we're now creating, nothing else is existing, just the template and the swarm. So let's connect to that environment. That's a different one. See if we're still up and running. And I'll create that service. Copy and paste that one again. So let's start that one, and it has accepted it. So all I need to give that script is the image that I want to use. So that's just the same as if you're running Business Central locally. In that case, I'm using the latest one, CU1 in the W1 variation. And as I'm running on Windows Server 2019, I add the LTSC 2019. I also need to let it know what original database to use, and that has that particular name. I've already prepared that in advance. And then I give it a name and a password, and that password will be used when we connect using NAV. To give you an idea how that script looks like, I switch back to my environment. So the create service one looks like this. It gets the same commands that we've seen before. So the name, the image, the password for NAV, and the name of the original database. I also have an optional parameter to add some add-ins. So it would download a zip file and put it in the add-ins folder in case you have your own DLLs that you want to share. Then it does the traffic setup. And again, I won't go into detail there. That's something you can check in the previous webinar. And this is the add-ins download part. So this is basically not connected to Docker Swarm. And then we have the actual Docker service create. That one now looks a bit more difficult or more complex than what we did before. But basically, it's mostly labels, as we see in a minute. So we're doing the same Docker service create that we did before. We give it a name. We also need to let it know that it can take up to 15 minutes to create the database copy. Hopefully we will be a lot quicker, so I can show you the result. But depending on your database size, it might take a couple of minutes to restore that template database into a copy. And because of that, I have updated the health start period so that Docker Swarm knows that if it's not going healthy for the first 15 minutes, we're still fine. It uses the network that's set up, a host name, that's kind of standard Docker run. We, of course, need to accept the end user license agreement. I'm also accepting it if the container image is outdated, because I might run an old image as well. I give it a different web server instance name and public DNS name. That's more around the networking stuff. And then I'm setting up a lot of environment variables, to let it know which database I want to connect to, what the original database is, where I want to copy it, the username and the password, and a lot of labels for traffic. And then, as I shared in the beginning, there's a concept of secrets and of configurations that I can share in a swarm, and those are mentioned here. I'll show you soon how those are created. And we can just access them by name. So we need the application ID and the account secret, which basically is username and password in the Azure world. We have a secret for the SQL password. We have a configuration for the Azure subscription we are using, for the resource group, for the server name, and so on. And that's just a way to share those configurations and secrets with the service. So you can't just access all the configurations and all the secrets, but just those that were set up during service create. Again, I'm putting this anywhere but on the manager, and I'm limiting the memory usage to 12 gigabytes in that case. How are the configurations and the secrets set up? That's a different script that I've also run before. And what I'm doing here is some Azure stuff. I'm creating an Azure AD service principal, which means a user that is allowed to connect to the SQL server, that is allowed to read my subscription so that it can log in, and it also is allowed access to the target SQL server. So this is the one where I'm reading from, and this is the one that that's the one where I'm creating the database, and this is the one where I'm reading the database from. That way, by using this service principal, I'm sure that if someone stole my container or got access to that one, it will still only be able to connect to the SQL database and nothing else in my Azure subscription. And that's basically a security measure. And of course, I need access to the database, otherwise it won't work. And then I'm using a helper function to set those Docker secrets and to set those Docker configurations. And that's kind of easy. It does a Docker config create for the configuration, and it does a Docker secret create for the secrets, and then we can use them as I've just shown you. And then what happens when this starts, I can show you that here. So when the container starts, the first thing that happens is navstart.ps1, and it imports the Azure stuff, as we will be using a couple of Azure commandlets. That takes a minute or two, unfortunately. Then it's logging in using the credentials that we've just created using that Azure AD principle. It checks to find out if the target database already exists. So if the database is already in place and I'm just recreating the container, I don't want to create a new copy of the database. I just use the one that is already there. But if it's not there, I'm creating a database copy. That is done with that command, new Azure SQL database copy. I need to give it the original server and the original database, and the target server and the target database, and the elastic pool that I want to use. And with that, when the container is starting, it just creates the database and then connects to it in the further startup of the container. And if I've now talked long enough, let's see. That's a different machine, but also Portainer. We do have that service, and we do have a couple of tasks, and that one says running, so that looks good. Let's see what we can see in the log file. That also looks good. So it has started. It has imported the Azure modules as we've just seen. It has checked if the target database already exists. Now, in that case, it says the resource was not found, so the database was not already there. And now it has created a database copy. So it used my database here, and it copied it to the database that's called like this. And now I can connect. And after that, after those 3 minutes in that case, the usual initialization of the Business Central container starts. It's doing all the regular stuff, and it's connecting to the SQL server that I've provided. Okay.
Tobias?
Yeah, sure.
Okay. So we've got 15 minutes left. There are no questions yet. So I just wanted to let everybody know that's listening. If you have any questions, we will have I think, will you have time for questions?
Absolutely.
Yeah, so please, if anyone's got any questions, we'll be having a question time in a few minutes. But yeah, continue and I'll let you know if there's any questions. So we've got 15 minutes left, yeah?
Okay. I just want to show you the connection, and I hope that we are able to log in. Well, let's see here, and that looks good. At the same time, I wanted to show you that this also should work on the mobile, as with a recent fix I've implemented. And the screen sharing doesn't work. Let's try again. Yeah, with a recent fix, I've implemented a fix so that now the mobile access should work as well, but my phone doesn't want to connect. Let's try to log in again. Reconnect. Yes, and now hopefully we should be up and running. Yes. So if I open the Business Central environment here and put in the name that we just used, and I need to type this on my mobile. And use the same URL that we've just used. And we should hopefully be able to connect. I need to give it the password as well. And now you know my super secret password. Nope. So with that, we should be able to connect using the mobile client as well. So again, this is going through traffic, connecting to the container that is running on my Swarm, and that in turn is connected to the Azure SQL database. So that one works as well. In the meantime, the web client, the web client has also connected, so we're connected there as well. I can also use the modern Windows client. Start that one. That's opening on a different screen. So we're connecting that one to the same environment. It doesn't want to connect. Why not? That's weird. That should work. Let me see if the fallback one wants to work. No. Okay. Sorry about that one. That should work as well. Not sure what I'm missing at the moment. Yeah, sorry about that one. Not sure what goes wrong here. That should also work. And the last thing that I wanted to show you is, because we're now using Azure SQL, we can use the Azure portal to connect here as well. And if we log in here, we can see all the environments, and we can see the database that was just created on demand. So that's the server. You can see here we have a pool, and we have the database that was just now created. So that one is just recently up and running. As you can see here, it doesn't have any resource consumption before like 10 minutes ago, because it was only created 10 minutes ago. And now we can use all the Azure features that are there. We can connect using Power BI, Power Apps, Flow, or we can use the query editor. Oh, if I remember the password and can type it. Sorry, that's firewall protected. And I couldn't set that up before because that one was just now created. Let's see, we go back to the query editor. Where is it? Need to go to the database and then to the query editor and put in my username and password, and now we are in. And now I can do all the usual SQL stuff that I can do on a Business Central database. You can see here I already got the IntelliSense, and let's see what we can get here. Of course. So we get the Kronos International codes. That's just the company that is pre-set up here. So that one works as well, and I can use all the tooling that is available by using Azure SQL to connect here. No need to set anything up additionally. Okay, with that, I am coming to an end of my presentation. We've seen that one. So I want to thank you for your time, for taking the time to participate here. I'm of course open to answering any questions that you might have. And I wanted to point out two things. First one is that link, bit.ly dockerprod. That one would be the Dynamics Ideas site where you can vote for production support for Docker containers. So if you agree with me that dev and test is nice, but actually we would want to use this in production, please go here and vote for that one. And another one would be that we have currently database development licenses that are limited to 120 kilobytes, which seems kind of ridiculous in the year 2019. So you might want to vote here as well to get rid of that limitation. So with that, again, thanks a lot. And I'm, of course, open for any questions.
Yeah, we don't have any questions at the moment. Christian had his hand raised, but I think it might have just been accidentally clicked. Does anyone have a question? I can see we've got most of the people still on the session, and they're listening at the moment, or they're active. But no questions, it looks like. Okay. Yeah, Christian's had a question about quota limits. Can you, yeah, I don't know if maybe the, can you put it in the question bar, Christian? Yeah, okay. Is the question bar working? So can you just type a question in the question? Okay, so I ran into a limit issue when trying to start the swarm.
What kind of limit?
Can I make? There we go. Julian, I've got your question. 1 second, yeah? Oh, here we go. I can't really see that in the chat thing, Christian. Sorry, it needs to be in the question. Let me just see if I can. It's very hard to see because Christian's put it in the chat and I can't really see in the chat. Here we go.
Christian, I'm also open to discuss this via email or Twitter, whatever works for you. So
yeah, let me just put this in here. Christian, you should see in the question window, you should see Christian's message. But in the meantime, Julian has asked, could you please show us the Portainer IO for the BC Swarm, please?
Sure, let's go back here. So this again would be the BC Swarm. I guess you're talking about the visualizer. That's the same as before. I, in that case, only have provided 2 workers, the same basic setup. And if we look at the visualizer there, you can see that we have the same base setup. So everyone's running the agent. The manager is running Portainer and traffic, as we're using that on the manager. And then we have the service that we just created, which is running Business Central. And we have the fallback one that I've pre-created in case anything.
Okay, I ran into an issue when trying to start the Bear Swarm, and it tells me that I can only allocate 10 cores.
Okay, yeah, that is a limitation that you run into, because by default, The resource limits that you're getting on Azure are not very big, but the solution, fortunately, is kind of easy. If you go to the Azure portal, let's ignore that one, to the Azure portal, let me see if I can find that one. No, it's something like quota and limits. Oh. In subscription, let's take that one. Look at the usage and quotas, and then you will see here, if you check for the providers, the compute, then you should see limits in place. You can see here that I have somewhat bigger numbers because I've requested an increase. If it says something like you don't have more than 10, then you should see 10. I actually think the default should be 20, but I might be wrong there. But what you can always do is you can request an increase. So you just click on that button. It says request increase, and then you just need to fill in the information. What do you want to do? I want to have more resources. It will ask you which region you want to use and which particular type of a quota. So is it the CPU limit or a storage limit or whatever? And then you can just request that one. If you're requesting a lot, you might get a question back. So I did this for my workshops on NAV TechDays, and I just requested like 1,200 CPUs because I actually miscalculated how much I need. I didn't need that much. But then they got back and asked, do you really need that much? And when do you need it? And can we have some kind of a ramp up? And when do you want to use them? And so on. But after giving them that information, they were happy to increase that as well. And if you just scale in a reasonable amount, like I now need 100 CPUs, then usually you just get an answer back saying, yeah, you're fine, you can go ahead now. So this is the way to get across that limitation.
Okay, that seems to have answered Christian's question. Thanks for that. So we've got 2 more minutes, but I think there's no more questions. Any other questions? Otherwise, I think we can wind up. Okay, so thank you, everybody. Thank you very much, Tobias. It was very detailed. I'm actually going to go back and rewatch your earlier presentation from last month because I was sort of sitting in the background and I realized I missed a lot on that one. So I'm going to rewatch that one. I think this one, then I'll rewatch this one because there was a lot of good stuff in here and I could see I needed to know more. Christian, yes, everything is recorded. So I'm just going to take that controller presentation for a moment, yeah?
Yeah.
But everything is recorded. If you subscribe on this EE Plural thing, it will automatically send you links to everything. So yes, all available on a thing, because obviously Tobias gave us a lot of information here, too much to gather in 1 hour, and I think it's going to need 2 or 3 watchings to get a lot out of this information. So again, thank you very much.